Hi everyone, this is Group 5 and our project is on indirect QA model analysis using transfer learning. The indirect QA task aims to understand indirect responses to naturally occurring Boolean questions without the use of direct Q words. So an example would be, do you want to get dinner? And I'd rather just go to bed. Researchers at Google created this circuit corpus with 34,000 such QA pairs treated as a multi-class classification with 4 to 6 different labels. They then tested out this dataset using a BERT-based model, which was fine-tuned to just the circuit dataset and a combination of BoolQ and MNLI. The development of such models can be used to improve the performance of conversational chatbots and other AI agents, which is why within the scope of this project, we experimented with different transfer learning models to potentially achieve better results.
Our team replicated each of these BERT-based models and achieved similar performance to the researchers. The first transfer learning model that we applied was Roberto, and we thought that this would perform well on the Circa dataset because it is an extension of the BERT model which the researchers used as a baseline. Robustly optimized BERT pre-training approach optimizes for BERT's hyperparameters and training size by applying longer training and using bigger batches. In particular, it achieves state-of-the-art performance on glue, race, and squad. Our Roberta model, fine-tuned on MNLI and Circle, performed better than the baseline for both the strict and relaxed settings.
The text-to-text transfer transformer, or the T5, uses text sequences as both the input and the output, which distinguishes it from other transformer-based architectures. The model was trained on the huge C4 corpus of English text, and it offers flexibility of applying the same model to different NLP tasks. However, our results did not outperform the baseline models.
Unified QA is a recent model that is pre-trained on 4 different QA tasks of different formats, and fine-tuning this model has been shown to achieve state-of-the-art on 10 unseen QA datasets. We believe that it might be able to perform well on the Circa dataset because it aims to understand linguistic reasoning abilities that generalize across formats. Additionally, since this model is pre-trained on 8 datasets including BoolQ, we decided to study how it performs when it is directly fine-tuned on the Circa dataset without any intermediate steps. This model outperformed the baseline on the relaxed setting but not on the strict setting. It did not perform well on the classes that had a low proportion of instances in the training set, so we think that it perhaps did not have enough examples to learn the identifying linguistic features for these classes.
Thank you very much for your time and attention today, and now we will open it up to any questions from the class or the crowd.